equations in pre-algebra. Not necessarily how to do it. Hopefully you remember how to do it, but at least you remember going over it in class.
Yes.
Yes, okay. Do what? Okay. Okay. Well, hopefully, like I said, this will jog our memories, and we will get into a little more complex equations than you probably got to in pre-algebra. Okay? So today we are solving simple equations. Let's talk about an equation real quick. What do you know about an equation? Numbers, variables probably, right? What makes it an equation though? What sign? What specific sign makes it an equation? Equal sign, right? If it's got an equal sign, I know it's an equation. We all know what equal signs look like, right? Okay. What does equals mean?
The same as.
Same as, right? So the left side of the equation equals the same thing as the right side of the equation, right? It'd probably look different, but it means they're the same. Does everyone agree with that? So, I always like to explain it like you guys know those balances or scales, whatever you want to call them, where you want to keep it level, right? You want to keep both sides at the same level. If I want to keep them both level, what's going to happen if I add 2 pounds over here to this side?
It's going to go down.
It's going to go down. This side's going to go up, right? So if I want to keep it level, what do I have to do to this side as well? Add 2 pounds, right? If I subtract 5 pounds from this side, what's going to happen? It's going to go up. This side's going to go down. So what do I have to do over here? Subtract 5 pounds and it'll level out. If I multiply this side by 2, I double its weight. It's going to go down. This side's going to go up. So what do I have to do to this side? Double the weight. If I cut this side in half, it's going to go up. So what do I have to do to this side? Cut that side in half, right? So since both sides of my equation are the same thing, whatever I do to one side, I have to do the exact same thing to the other. Does that make sense? Do we remember that from pre-algebra?
Yes.
Yes. If not, does that make sense though?
Yes.
Why do we have to do that?
To make it equal.
Yeah, exactly. To make it even, keep it equal. Because it's already equal. So whatever I do to one side, I have to do to the other. Keep it the exact same. Okay? Everyone okay with that?
Yeah.
Okay. When we're solving our equations, we also use these things called inverse operations. Does anyone know what the word inverse means? Opposite, right? So what's the inverse of addition? Subtraction. What's the inverse of subtraction? Addition. What's the inverse of multiplication? Division. What's the inverse of division? Multiplication. Do we understand those concepts? So, if something's being added on one side and I want to get rid of it, I've got to subtract it. If something's being subtracted, I got to add it to get rid of it. If something's being multiplied, I got to divide. If something's being divided, I got to multiply. We all understand what inverse operations mean?
Yes.
Okay. We're going to kind of combine 1.3 and 1.4 today. So 1.3 is titled Solving Simple Equations. In other words, they're going to be just one-step equations. It's going to be only one step to solve my equations. When I'm solving my equation, my goal is to get the variable by itself. Isolated to one side of the equation all by itself. Nothing being multiplied by it, nothing being divided by it, nothing being added to it, nothing being subtracted from it.
Oh, I remember how to do these.
We okay with that? Okay. So this is where our inverse operations come into play. So number 1, I've got x minus 3 equals negative 5. X minus 3 equals negative 5. And notice the directions tell me to solve the equation. What's the second part tell me to do? Check your solution. If I asked you to check your solution, I want you to check it, and I'll show you how to do that here in a second after we solve it. So, what numbers are on the left-hand side of the equation
3.
with x?
Negative
3, right? If we're just looking at the left side of the equation, because that's where the variable is, that 3 is with the x. What's the operation going on between that x and that 3?
3.
Subtraction, right? It's x minus 3. What do we say the inverse of subtraction was? Addition. So if I'm trying to get x by itself, I'm trying to get rid of that minus 3, correct? So what's the inverse of subtracting 3? Adding 3. Because what is negative 3 plus 3? 0. So it cancels out on that side of the equation. It's gone. Right? Everyone okay with that? And everyone understand why I did that? So I'm trying to get x by itself. Okay, I did something to the left-hand side of my equation. You got to do the same thing to the right side of the equation. Okay? So I've got to add 3. If you need to, I've seen people do this before, you can cut your equation down the equal sign. And that equal sign just follows that line down, so whatever I do to one side of that line, I got to do to the other side of that line. Some people will sometimes get confused, and they'll say, oh, I add 3 here, and then they don't necessarily understand what I mean when I say both sides of the equation, so they say, oh, I got to add 3 to x as well. Is that doing something to both sides of the equation? No. So do we all understand what I mean when I say both sides of the equation? Both sides of the equal sign. Okay? So don't do that. Got to add it to the right side of the equal sign as well. So we said our 3's cancel out on the left, correct? So what am I left with on the left-hand side? Just x, right? And then what's negative 5 plus 3 on that right-hand side? Negative 2. Is my variable now isolated by itself on one side of the equation? Yeah. Nothing's being multiplied by it besides 1. Nothing's being divided by it. Nothing's being added to it. And nothing's being subtracted from it. So I know I have now solved my equation. We okay with that? Okay. Can anyone raise your hand and explain to me how I check my solution?
You gotta divide something about
All right. Say it again. Yeah, I'm saying x equals negative 2. So I can plug this answer back into my original equation. Replace the x with negative 2. And now I just work down both sides of the equation. If I get a true statement, I know my answer is correct. If I get a false statement, I know my answer is wrong. So my right side's already worked out for me, isn't it? There's nothing else I can do over here. So I'm just going to bring that down. But I can combine negative 2 and negative 3 here. What's negative 2 minus 3? Negative 5. Negative 5 equals negative 5. Is that a true or false statement? True. I know my answer checks out. I know negative 2 is correct. Everyone okay with that?
Yep.
How do we feel after our first example?
Amazing.
Amazing. That's what I like to hear. Huh? Muy bien. Okay. Not in Spanish, but that's okay. Any questions before I move to number 2? All right, number 2. 0.9 excuse me, equals y plus 2.8. 0.9 equals y plus 2.8. Does it matter that my variable is on the right side of the equation?
No.
No, I can still solve my equation for my variable, right?
Yep.
Okay. So what number is on the same side of the equation as the y?
2.8.
2.8, right? What's the operation going on between y and 2.8?
Addition.
Addition. What do we say the inverse of addition was?
Subtraction.
Subtraction. So what do I need to do to my right side to get y by itself?
Subtract.
Subtract 2.8. Because 2.8 minus 2.8 would give me 0. It's canceled out. So I've done one thing to my right-hand side of the equation. What do I need to do to my left hand now?
The same thing.
Same thing. Subtract 2.8 from both sides. What's left on the right-hand side? Y. And 0.9 minus 2.8 would give me what? Say it again. Not negative 2.1. Go for it. Actually, go for it.
Is it like 1.8? 1.9?
I don't know. What does the calculator say?
Yeah, I thought it was 1.9.
You can go to your seat while you're doing it.
Yo, Steve.
Oh, my fault.
Dang.
It will be negative.
says negative 1.9.
There we go.
I said that.
No, you didn't.
Is my variable now by itself on one side of the equation? Yeah, so now I've solved my equation. Okay? But what do I need to do?
Check your answer.
Check your solution. So I plug in my solution to my original equation. Is the left side of my equation already worked out for me?
Yes.
Yeah, I can't do anything else over here, can I?
No.
Okay, what's negative 1.9 plus 2.8?
1 point, negative 1. Wait.
It'd be
1.9.
1.9.
Say what?
1.9.
No, 1.9.
Oh, shoot. Negative 1.9.
No.
Oh, shoot.
What's negative 1.9 plus 2.8? We got calculators, right?
2.8.
0.9.
0.9.
Oh, that's what I meant.
Is it?
No, probably.
Oh, okay. So, let's look at the statement that's left over after I work down both sides of the equations. 0.9 equals 0.9. Is that true or false?
True.
True? And my answer checks out. Questions 1, 2. We're good with that. So these two examples show one step to solve our equation. One step was addition, the other step was subtraction. So what do you think are going to be our next steps on the next slide? Multiplication and division. Here we go. Solve each equation, check your answer. Letter A, I've got negative n over 5 equals negative 3. Negative n over 5 equals negative 3. So what number is on the same side of the equation as the n? 5, right? What's the operation going on between n and 5? Division. Fraction is just division, correct? So what's the inverse of division? Multiplication. So what do I need to do to get rid of that 5? Multiply by 5, right? Not divide by 5. Multiply by 5, right? Okay. When I do that, my 5s are going to cancel out with each other. I see a little bit of an issue here, though. I'm going to get a negative n if I do that. Anyone see a solution here on how I could get rid of that negative?
Add it.
Not quite.
You gotta flip it,
What do you mean?
like put in one under the N and then flip.
No, I don't have to do that right now. What could I tack on to this 5 that I multiplied by?
Oh, negative.
Negative. If I do that, the negative goes away. Does everyone see that? Since that negative is just in front of my fraction, it can either go with the n or it can go with the 5. So I'm just saying, hey, let's make it go with the 5. That way I can cancel it when I take my one step. Everyone agree with that? Everyone understand that? All right. So I've multiplied my left side by negative 5. It's an equation, though, so what do I have to do to my right-hand side? Same thing, multiply by negative 5. So what's negative 3 times negative 5? Positive 15. Is my equation now solved for my variable? My variable is now by itself. So there's my answer. Questions on A? But we need to check our answer, so just plug it back in. Negative 15 divided by 5 gives me negative 15 divided by 5 gives me negative 3. My right side's already worked out for me. Do I get a true or false statement? True. And then my answer is correct. Questions on that? All right. I'm going to kind of pick up the pace a little bit. Letter B. Pi x equals negative 2. Pi x equals negative 2. What's the number that's on the same side as the variable? 3.14, or we could just say pi, right? Pi is on the same side as x. Pi is just a number, correct? A lot of people just look at pi right here and say, oh, that's a variable. I've got a variable times a variable here. That's not the case. We just have a symbol to represent pi. It's still just a number, though, right? So I'm going to treat it like a number. So what's the operation going on between pi and x?
Multiplication.
Multiplication. What's the inverse of multiplication? Division. So I'm going to divide by pi to cancel the pi out on that left-hand side. Everyone okay with that? Whatever I do to one side, I've got to do to the other. So x is now by itself. There is a pi button in your calculator, so you could type that in if you wanted to. So someone type in -2 divided by, and then find the pi button for me and hit pi and hit enter.
It says -0.6.
-0.6. So you could write it as a decimal. If you left it like this, I'd be okay with that as well. Okay? Either way. Do we all understand how to check our solutions?
Yes.
So to save time, is it okay if I stop checking my solutions in the notes?
Yes.
If it asks you to do it on your assignment, you do need to do it. But for time's sake, I'm not going to do it on the notes, okay? Unless I need to. Does someone need to see me checking my solution? Okay. Letter C. 1.3z equals 5.2. What number is on the same side of the equation as the variable? 1.3. What's the operation going on between that number and that variable? Multiplication. What's the inverse of multiplication? Division. So I've got to divide by what? 1.3. So it'll cancel over here. If I do something to the left, I have to do it to the right as well. What'd you say? 40? 5.2 divided by 1.3.
Oh, I didn't see that point there.
Hmm.
I thought that says 52. So what's that?
It's 4.
There we go. There's my answer. Questions on C?
No.
We're feeling okay with simple one-step equations? All right, can I move on?
Yes, sir.
Now we're not done with our notes. Here's the first part of your assignment. It's not that bad. It's like 12 problems, and they're all one-step equations. It's like 12 one-step equations.
Yeah, that's like,
Yeah. So it's probably like 6, adding, subtracting, 6, multiply, dividing. Check your solution. Should go pretty quick. That. So get that written down, and then we got our last section of notes for the day.
What's there?
Everyone got this written down so I can move on?
Oh, no.
Yeah, I just write it wherever you left off your notes. That's part 1. We got it written down. All right. Now let's move to 1.4, multi-step equations. We just solved single one-step equations. Now let's solve multi-step equations. So, straight into an example. Solve 2.5x minus 13 equals 2. Check your solution. So now it's not just adding or subtracting or multiplying or dividing. I'm going to have at least 2 steps, maybe more. That's why it's called multi-steps. Well, this one's going to be 2 steps because that's what the title of the slide is. So when I'm solving an equation for a variable, and I've got more than the one step, before I focus on getting the variable by itself, I need to get the term containing the variable by itself. Do we all know what terms are? Terms are separated by signs, so like addition and subtraction. So I've got a term here and a term here, because there's a minus sign between them. Does that make sense? So which term contains my variable? 2.5x, right? That's one term right there, 2.5x. So before I get x by itself, I've got to get that term by itself first. So how would I get this term by itself? Yeah, I got to get rid of this 13. That's on the same side of the equation as it.
Yes, sir.
Does that make sense? So what'd you say to do?
Plus 13.
Plus 13, yeah. That cancels out my 13. Whatever I do to one side, we got to do to the other. Is everyone following me? Okay. So I still have this 2.5x over here. And then on the right-hand side, what's 2 plus 13? 15. Any confusion after that first step? Yeah.
Oh, no, I was.
Okay, I got you. Any confusion after that first step? Okay. Now, is the term that contains the variable now by itself on one side of the equation?
Yes.
Yes. After I get the term containing the variable by itself, I can then focus on getting the variable by itself. So now, what's the number with the variable?
2.5.
2.5. What's the operation going on between those?
Multiplication.
Multiplication. What's the inverse of multiplication?
Division.
Division. So divide both sides by 2.5, so it'll cancel out over here. Whatever I do to one side, I have to do to the other.
6.
What'd you say?
6.
6. 15 divided by 2.5 gives me 6. Questions on how I got that? Now, when I check my solution here, once again, plugging into my original equation, I'm still working down both sides of the equation. Here, though, I just have to use my order of operations. So I'd have to do multiplication first. 2.5 times 6 would give me 15. And then I'll do my subtraction. 15 minus 13 gives me 2. Is that true or false? True. Okay. Questions on this example? You feel okay about multi-step so far? Or 2 steps at least? Okay. Can I move on? Last 2 examples here. Solve each equation, check your solution. Number 1, I've got negative 12 equals 9x minus 6x plus 15. Negative 12 equals 9x minus 6x plus 15. Any ideas what I'm going to need to do here first? Not quite. Combine like terms, yes. So, when I get to longer equations like this, what I need to do first and foremost is look at simplifying both sides of the equation if I'm able to. See if anything can combine. Can I do anything on the left-hand side of the equation? No, it's just a negative 12. It's just sitting there chilling, right? On the right-hand side, though, I do have some like terms. What are my like terms here? 9x and negative 6x, right? So before I start to do any solving, I need to simplify my sides of my equation. And combining like terms does count as simplifying. Do we know how to combine like terms? Yeah, what would 9x minus 6x give me? 3x. I just subtract the coefficients, leave the variable the same. Can I do any more simplifying on this right-hand side? No. This just looks like a problem we just solved, right? It's got a number times a variable. Adding a number to it equal to another number. Okay? So, now I need to try to get the term containing the variable by itself. So what's the term that contains the variable? 3x, right? So what do I need to get away from 3x? 15, because it's on the same side of the equation as it. So how would I get rid of that positive 15, the plus 15? Subtract 15 to cancel it out. Whatever I do to one side, got to do to the other. Negative 12 minus 15. Negative 27, yep. Am I moving too fast for anybody? Slow down if I need to. Is the term containing the variable by itself? Yeah, the term containing the variable, 3x, is now by itself. Once I do that, now I can focus on getting the variable by itself. So what's with the variable now?
Multiplication.
What's with the variable now?
Oh, 3.
3, and what's the operation going on between them? There we go. What's the inverse of multiplication? Division. So am I dividing by negative 27 or by 3? By 3. Dividing by the number that's with the variable. So it'll cancel. What I do to one side, I got to do to the other. Negative 27 divided by 3 gives me negative 9. Is my variable now by itself? Yes, it is. Questions there? Now here, when I plug in to check my answer, I've got to plug into both x's. Use your order of operations. Work down this right side. This left side's already worked out for you. Okay? Questions on 1?
No.
Can I move on to number 2?
Yeah.
Last example of the day. 2 times 1 minus x plus 3 equals negative 8. 2 times 1 minus x plus 3 equals negative 8. Any ideas what to do first here? Distribute. Do you guys remember the distributive property? Yeah. If I've got a number times a set of parentheses, I can distribute that number through the set of parentheses, which means I'm multiplying this number by every term in the parentheses. Right? So I'm doing 2 times 1 and 2 times negative x. You guys remember that? Hopefully. So what would 2 times 1 give me? 2. 2 times negative x? Negative 2x. I still have that plus 3 equals negative 8. We okay with my first step? Any confusion there? Okay, what do I need to do now? Combine like terms. Which side of the equation, left or right? Left. What are my like terms here? 2 and 3. Everyone agree with that? Those are called constant terms. A constant is a number without a variable. If I have 2 constants, I can combine them. They are like terms. So what is 2 plus 3? 5. So I'm leaving my negative 2x the same, leaving my negative 8 the same on the right-hand side. We okay with that? Okay. Is the term containing the variable by itself on one side of the equation? Well, first off, what is my term containing the variable? Negative 2x. So is negative 2x by itself on one side of the equation? No, what's with it? 5. It's negative 2x plus 5. So how would I get rid of that plus 5? How? Yeah. Yeah, subtract 5. Because 5 minus 5 is going to give me 0. What I do to one side, got to do to the other. So I get negative 2x equals, what's negative 8 minus 5? Negative 13. Is the term containing my variable now by itself? Yeah, it is. So now I can get the variable by itself. What's with the variable? What number? Negative 2. And the operation you guys said is multiplication. What's the inverse of multiplication? So I got to divide both sides by negative 2. So x equals, what's negative 13 divided by negative 2? 6.5. Questions there? If it asks you to check your solution, I do need you to check it. I need you to show all of your work on your assignments. Even on those one-step equations, I need to see your one step. Does everyone got me? It's x minus 3. I need to see you put plus 3 below it and plus 3 to the other side. Okay? I need to see all your work, and then I need to see all your work checking your solution. Questions, comments, concerns? Here's the second part of our assignment. Page 28, numbers 4 through 24 evens. Like I said earlier, the first set of problems are just all one-step equations. Those should go pretty quick. This section should probably take just a tad bit longer, but not too terribly much longer. Okay? But these are going to be these are the same assignment. Keep them together on the same sheet of paper. Okay? So whenever you're doing your heading on your paper, whenever you have your assignment in the very last row, you need to include both page numbers with both sets of numbers. Okay? Does that make sense? Okay. Make sure you have the correct heading on your paper. This assignment will be due Wednesday. That'll be the 24th. On campus. Today's the 22nd. If you guys ever don't know the date, I've got my calendar back there. I update it per day so you can see what day it is. Okay? So this will be due Wednesday the 24th on Canvas. That's also when your signed syllabus is due. Okay? Do we have any questions about my notes before I end the recording?
No.
Sweet.